know you see me. All right, Sean. What's today, Sean? Guess what day it is? Hey, yeah. All right, here we go. Yesterday. Today's when. Isn't that funny that when I speak, you keep talking, but when I don't talk, you stop? That's kind of weird. Today's Wednesday, March 11th, year of our Lord 2020. You did 1 through 19 yesterday. You got to listen fast because I'm going to talk fast. We did a lot of these already yesterday, but here they go. Ready? A transformation is G, an operation that changes one figure into another. Number 2, reflection is E, a transformation that creates a mirror image of a figure. What? Hold on. There's one chief here. Guess who it's not? Excuse me? You. Number 3. Are you trying to be funny?
No, I'm not.
Okay, shh. Number 1, a transformation is G, an operation that changes one figure into another. Number 2, reflection is E, a transformation that creates a mirror image. If that was matching on a test, reflection, mirror, you almost have to not even be in class to know that one, right? It's not going to be matching on a test. Number 3, parallel lines, F, 2 lines in the same plane that do not intersect. Never will they intersect. They're parallel. Number 4, complementary with an E in the middle. Complementary is 2 angles whose measures have a sum of 90. Together they make 90. 90-degree angles are very important in life, in the world. They're all around you. Next, supplementary angles are C, 2 angles whose measure have a sum of 180. Straight lines are all around you. Important to know about straight lines and right angles and triangles. They're all over the place. Number 6, perpendicular lines. 2 lines that intersect to form a right angle. Number 7, translation is D, a transformation that slides a figure. Translation slides. If that helps, I hope that helps somebody. Translation, SL, slides a figure. And number 8, which we didn't get too far into, dilation is a transformation that stretches or shrinks a figure. Maybe like, think of it as zoom on your computer screen. Okay, it's the same thing, right? You ever bring up a picture and you go like this and make it bigger? Isn't everything the same?
Yeah.
It's just proportionally, everything proportionally got larger. You dilated it. Make sense? Okay. Number 9. Okay, I'm sorry, Noah. What, buddy?
What letter was it?
Number 8 was B, bud. That was the only one left, wasn't it?
Yeah.
You good, Noah?
Yeah.
Number 9. The measure of angle 1. How do you know the measure of angle 1? Don't tell me the answer. Tell me how you knew the answer. Dina.
Because it was like the intersecting line.
What do you call those opposite angles that are created by intersecting lines?
I forget the name.
Come on. You can't forget the names. You got to start speaking the language. You learn German and German. I was going to say, whoa, stop, but then I knew that would be like a bad pun. I just learned that yesterday, by the way.
What?
Whoa.
Oh, yeah.
Dominic. They're called vertical angles.
Yeah, that.
Yes.
And
You're speaking algebra E's. So since they're vertical angles, what's the measure of angle 1?
it's 109.
Everybody got that?
Yep.
109. Noah, it has to be 109 because it's the 2 lines intersect and its opposite angle is 109. You get that? You sure? Because they're called what? Vertical angles. Say it yourself. What are vertical angles? I want you to repeat it with your ladies. Say it with your own words so you're confident tomorrow. What are vertical angles?
The opposite side of the other angle.
They're angles created by intersecting lines.
Okay.
Opposite angles created by intersecting lines, and they must be equal or congruent. Number 10. Don't just give me the answer. Tell me why it's that answer. Jaden.
Is it 130?
It's 130. Why?
Because it has to make equal 180 because it's a straight line.
Because angle 1 and 50 have to equal 180. 180 minus 50 is 130. Number 11. Tell us why angle 1 has to be the degrees you said. Brett. Why?
Because there's a right angle on the left side and that's 90 degrees and then it's 180. It has to add 180.
Brett says all three of those angles must add up to 180 because they create a straight line. What do you know so far? 90 and 65. What's left? 25. Number 12. How would you classify that triangle? I told you yesterday there's two answers. You can classify triangles by their angles, or you can classify triangles by their sides. God bless you. How do you classify number 12, Dominic?
Obtuse and isosceles.
Why is it obtuse?
Because one angle is greater than 90.
As soon as any triangle has an angle greater than 90, we say it's obtuse. If all the angles are less than 90, we say it's a cute little angle because they're all small. And if a triangle has a 90-degree angle, we call it a right triangle because it has a right angle. What if a triangle has two right angles? Thank you. That's not possible. I had some people thinking a triangle can't have two right angles. Micah knows because 90 and 90 is 180. There would be no degrees for the third angle, right, Micah? You can't have a, no, there's no zero. Listen, did you hear that? I'm not dismissing that. That's not as crazy as it sounds. Can there be an angle? Never got asked that before. That's not a silly question. Can there be an angle of 0 degrees?
Yeah.
No, there'd be no side. It'd be like no edge. There'd be no.
What would it be?
A line.
What's a line? How many degrees?
180.
180. Because angles are created by two rays that share that common endpoint, and we're measuring degrees in the opening between the two rays, right? So there's no opening, it's just a line, it's just a ray, which is a line with an endpoint.
So you can't.
So there's no 0, right? So you can't have two right angles in a right triangle, or any triangle. Number 13, there is only one label they wanted you to give for number 13. So if you're going to raise your hand and call it a simple closed figure, I'm going to say you got to be more specific. If you raise your hand and say I'm going to call that a polygon, I'm going to say you got to be more specific. If you raise your hand, you say that's a quadrilateral, I'm going to say you got to be more specific. If you raise your hand and say that that's a parallelogram, I'm going to say you got to be more specific. It's a, David, go ahead, buddy. You're chomping at the bit.
It's a square. It's a rectangle.
Did you ever hear something so not funny that you laughed?
Yeah.
I thought it was
All right. It's a rectangle. I think I'm off camera so I can make faces.
I say something and nobody laughs,
It's on,
I just
but
say
I'm not.
something random. Like, oh, Jesus.
All right, number 13. One label. I mean, besides the fact that it's a triangle. What kind of triangle would we call that? Kiara?
The square.
Equilateral. Now, she looks at that and she says all the angles are the same, all the sides are the same. What do I call it? Listen, if it's equilateral, it's also what you would call equiangular. We call it equilateral. So don't try to be fancy schmancy and call it equiangular. If they're equiangular, they are equilateral. Does it make sense? Did you have a question, Case? All right, number 15. Find the sum of the angular measures in a heptagon. In a heptagon, there's how many sides?
7.
7. We said yesterday, Noah, if you get confused between how many sides or what, because most kids get a grasp pretty quick on Pentagon 5. You might get confused. No, you get confused after that. You got the 2 H words, hex and hept. Hex has an X just like 6, so 6-side figure. And then hept kind of has the same, almost similar beginning as sept. And so you think of September, hept. And then I said, no, that's not really true. Because, and then some kids still get confused even though you're a couple years older. And we have to quickly explain, we got to quickly explain what we started yesterday, Dina. So listen, Dina. When they named the months of the year, it was before the present calendar. And there used to be 10 months, okay? The months of the year used to be March, April, May, June, July, August, September, October, November, December, which makes sense when you think about the names of the months, especially when you start with September, October, November, and December, because you know enough about language to know that now that you know hept is a 7-sided figure, sept would be 7, and you know that an octagon has 8 sides and an octopus has 8 arms, legs, tentacles, whatever you want to call them. So you know 8's oct, and you know nueve in Spanish is 9, nueve, 9, and you know decade has 10 years, and you know about the DEC meaning 10, the decimal system's based on powers of 10, so DEC means 10. So you would think that September would be the 7th month, October would be the 8th month, November would be the 9th month, December the 10th month. And they were. But when we went to the present day calendar, instead of having because there used to be, this is, you know, when they learned more about astronomy, and we operate on a solar year. You know what that means? That's why we have leap year. We have a day that we add on there because the best we can do to set up a day, the closest we can get is 24 hours for the sun to make, for the earth to make its rotation. The sun's not doing anything, going anywhere. The earth to make its rotation 24 hours, right? Well, it's not exact. We'd like it if it was like perfect, but it isn't. So we figured out it's not perfect. We figured out it's not perfectly 365 days for the earth to make its revolution around the sun. So when we got more precise with our time, they added 2 months and they put them at the beginning, January and February.
Why not the end?
Yeah, they should have put it at the end.
I don't know. They probably should have put it at the end because March, think about this, I make this argument all the time, they probably should have put it at the end because March is when spring starts, right?
Yeah.
And it always drives me crazy that we celebrate Happy New Year in the dead of winter where everything's dead. You look outside, a lot of times snow covered. When you say Happy New Year, like spring, new life coming, right? Flowers are budding and blooming. March makes sense to be the new year, which it was before.
And Christmas and New Year would have been further apart. Not so close.
There you go.
And I would have been.
But then we have a short Christmas break.
No, we have the same exact amount.
All right, here we go. Wait, I didn't even do number 15 yet. Everybody got that down now? All right. So here's how you do all polygons, Jordan. It doesn't matter what the polygon is. Here's your formula. Ready? N stands for number of sides. Parentheses. Take the number of sides, subtract 2.
7 minus 2.
Multiply it by 180. 7 minus 2 is 5. 5 times 180,
900.
900. Now, if they advance that question and they asked you how many degrees in one angle
Then you would
of a regular heptagon, what would you do with that 900?
divide by 7.
You divide it by 7. Hold on. What if they said find one angle of a heptagon?
Oh, that's it.
You wouldn't know because the key word I said there was find the measure of one angle of a
Regular.
regular heptagon because that tells you they're all the same. Amen?
Amen.
Isaac.
Couldn't you just relate the shapes to the months and then subtract 2 since they added 2? Like September, have subtract 2 and it's the 7th month.
Are you following that?
Yeah.
You subtract.
Oh, it makes sense.
All right,
You
Isaac.
just have to subtract.
Whatever works. Number 16.
It's 1.
Whatever it takes. Number 16. Find the measure of one angle in a regular pentagon. Same thing. 5-sided, minus 2 is 3. Noah, 3 times 180. You should have this memorized by now. 3 times 180 is 540. And it's a regular pentagon. So what am I going to divide by? So how many degrees in that angle? Number 16. Everybody said? Did somebody say 15?
Kira. No, I didn't say that.
108. Got it? All right. Number 17. You look at those two pentagons, and at first glance, you might not realize they're congruent, but you look a little closer at least, and you see that the one on the right is the one on the left, except they kind of just tilted it. You see how B is straight up 12 o'clock? You guys following my language here? Do you see how the point B on the left pentagon is straight up 12 o'clock? Come on. You're looking at the face of a clock, 12 straight up and down, right? 6 is at the bottom. Okay, so B straight up 12 o'clock. Do you see how the one on the right is the same pentagon except it's pointing to 11 o'clock? Who's following my logic? Who's following? You catching my drift here? It's the same pentagon except the top of it, the point's at 11 o'clock instead of 12 o'clock. I'm going to keep saying it until you all catch on here. Do you understand what I mean by 11 o'clock? You sure? Come on, Micah. Are you serious? Okay, David, let me put it in your terms. All right? This is going to happen to you maybe someday. You're going to the Campfield Fair or something. You're walking around with your buddy. He says, hey, David, 3 o'clock. Hurry up, look. There's a pretty girl standing there. You're going to go, there. Now do you understand?
Look at I did that.
What's the matter, Bella?
I mean, I'm like cute o'clock. Yeah.
Wait,
We
what?
call it.
That's a thing?
Yeah.
Wait, I just stumbled into something?
Yeah.
What's it called? It's called what?
We say cute o'clock, and then like a number, cute o'clock, when it is, and then we know how it goes.
Oh, cue the clock.
Cute.
Oh, cute o'clock.
Yep.
I'm good with this. Just keep going. Waste more time.
It's not.
I love wasting time.
I just walked into something I had no idea.
I know
about.
exactly what you're saying, but
Okay, but listen, you understand the point? Back to the point. The point Q is at 11 o'clock. Okay. All right, listen. They told you, though, in number 17 that they were congruent, right? So you should be able to see then, even Jonathan could see, that B corresponds with Q, and A corresponds with P, and C corresponds with R, and E corresponds with T, and D corresponds with S. Everybody got that? Because they're the same figure. Number 18. The congruent sides then are AE is congruent to PT. Everybody got that? Yeah. I don't have to do them all then. Number 19. Name the congruent triangles and explain how you know they are congruent. When they say name the triangle, don't get confused by that. How do you name a triangle? Come on. No, come on, don't be silly. How do you name a triangle? What? No, how do you name a triangle? It's way simpler than you're thinking. No! Please stop talking. Kira, how do you name a triangle? Shh. No! No, we're not. You're going too deep. We're not in. You name it by its vertices, the points that you name. So the triangle on the left is ABC. The triangle on the right is FGH. Hello. If you get asked this simple question on a test, and you have to do no figuring, name the triangle. What if I put a triangle on the test? A, one point, B, another point, C, and you miss it, and all it says is name the triangle. I don't give you any tick marks to say anything's equal or not, nothing. I don't tell you to figure anything out. I just say name the triangle. You're telling me you're not going to be able to do it?
No.
It's triangle A, B, C. That's it. It's written in the book like this. Triangle A, B, C. You act like you've never seen that before? That's all over your book.
It's the numbers.
And the other one is triangle F, G, H. Now, second part. How do you know they're congruent? Now you can answer the question you were trying to answer before that. How do you know those two are congruent, Kira? You were going to give us a proof that they were congruent. Side, angle, side. Jordan looks at these two triangles. She says that 10 and 6 are corresponding sides in both triangles, and in between them, they've got an equal sized angle. So we call that side, angle, side. Hello?
Yes.
What are the other two ways to prove triangles are congruent?
SSSASR.
Side, side, side. Hey, if all the sides are the same, it's the same triangle. Or angle, side, angle. If you've got an angle and another angle, and these two are the same, and the line in between them is the same, then the two triangles are congruent. The same. Okay, go to work, 20 through 29. That's all you got to do, but this isn't homework, by the way. The goal is that you would be done in less than 10 minutes, and you're either asking questions about this or something you're concerned about tomorrow's test, like, all right, I got to ask them this because I'm not quite sure about that yet.
I have a question about the
Test is tomorrow, dear.
I have a question.
We're not going to Franklin postponed in another day.
Is there a map on
20 through
the
29.
test?
Brett,
Let's do that.
I completely forget what side, angle, side, and side.
all right, so you're looking at two triangles, Brett. I'm not going to draw these perfectly, but I'll just put it up here for, yeah. All right, look, Brett, let's say I draw two triangles here. And I tell you they're congruent. We're not even going to worry about if they are or not, right? Because I'm not a perfect artist. I tell you those two triangles are congruent, but I have to prove it. So if we saw that this triangle, this was 6, and that was 7, and in this triangle, this was 6, and that was 7, and we said in this triangle, this angle was 105, and this angle was 105, and that's all the information we had. We would say that I know these two triangles are congruent. They're the same exact triangle. Why? Because two corresponding sides are congruent, and the angle in between them are congruent. So if two corresponding sides are the same, and the angle in between them is the same, we would say this is proven by side, angle, side. This side being congruent, this side being congruent, and the angle in between them. Get it? Side, the angle in between, and the other side. So we would say these two triangles are congruent, and I've proven it because of side, angle, side. So I don't have to measure these angles. Listen, the beauty of this, if you're wondering, Dominic would not have to measure these two angles in both triangles, nor would he have to measure this side. He already knows they have to be the same. Side, angle, side. Yeah.
Can you just flip the other triangle and it would be the same thing?
Well, what we're saying is these two are the exact same thing.
Yeah.
If you were to take this and go whoop, and place it on top, it would be the same. Make sense? Side, angle, side. So, Brett, not to try to be an artist, but let's say these two triangles are congruent, and now I'm going to prove it. Let's say that they told me that this angle, let's say they told me that in this triangle, these two angles were the same as those two angles. And they told me that this was 10 and that was 10. You know how I would prove it then? angle, side, angle. Two angles and the side they share, if those are congruent, then the whole both triangles are congruent. So this would be now angle, side, angle. And the easiest one, Brett, is, hey, if all the sides are the same length, they're congruent.
Why
Side,
wouldn't-
side, side.
Okay, but like it has those little squiggly or like the circle thingies.
Those
So why
angles.
Yeah, why wouldn't it be side angle, side angle, side angle?
I got nothing.
Or angle, angle, angle.
Well, okay, Kara, if it's side, 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 it goes without saying it's angle, angle, angle. So you don't, to have an AAA proof would be redundant. Did you hear that, Jonathan? We're going with, listen, what's Mr. Franken's motto? The only stupid question is the one that wasn't asked. So, why is there no AAA? Because it would be redundant. Do you guys know that vocab word?
Yes.
Yes.
Redundant means it's
He doesn't know my
repetitive.
English.
It would be redundant to have AAA because Jaden knows if all the sides are the same, then all the angles are the same. So if you already have a side, 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 you don't need an angle, angle, angle. No AAA needed because you got an SSS.
What?
Yeah.
SSS.
What are you trying to make out of that? Yes?
Double check.
Thankfully, there's no proof angle, side, side. Is that what you're saying? Are you trying to suggest where's the proof angle, side, side?
No.
Thankfully, there isn't one, so we don't have to deal with it.
You guys are gonna care?
So,
This one's wrong because I didn't go
Yeah. All right. Please stop the chatter. 24. Wait, does everybody understand 20 through 23?
yeah.
You just had to find out if those were reflections or not? Did you, listen, if you put yes for any of those except one, then you're not understanding. There's only one of those that's a reflection. Okay, number 24, triangle XYZ. Do you know why it's called triangle XYZ, Micah? Because the vertices of the triangle are X, Y, Z. Now you know how to name a triangle. X, Y, Z. Its vertices are -1, 1, -3, 1, -2, 5. You're going to reflect it in the Y-axis. Find the vertices of its image. Ready for my great artwork? Yeah. I don't need no stinking graph.
Are we gonna have graphs on the test?
Obviously, I got to figure out how to put one on there now.
Hello?
Okay. Whoop. All right, so without taking the time to make a whole graph, I've got my two axes that I need to worry about. The first triangle is -1, 1. -1, 1.
Flip them and then multiply with the y-axis.
-3, 1. 1, 2, 3, 1. And -2, 5. -2, 5. Okay, first of all, number 24. Micah, do you have a triangle that looks something like that? Everybody, 24? You graph the first triangle, it looks something like that in the second quadrant. Okay, now you want to reflect it over the the y-axis. So you want to reflect it this way, over the y-axis. So, you go back a few pages, and the rule says to reflect over the y-axis, you flip the coordinates, switch the coordinates, and multiply the new x by -1. Did I get that right? Let's check. Go back a few pages. Nope, I was using rotation.
I don't understand.
To reflect, you multiply its x coordinate by -1. You don't switch them. You just multiply the x by -1. Not for reflection, only for rotation.
Oh, okay.
Micah, you're going to reflect over the y-axis, so you multiply the x's by -1. So here's going to be my new image. Instead of -1, 1, it's going to be 1, 1. Wait, do you know why? Because -1 times -1 is +1. 1, 1. Then it's going to be not -3, 1, but 3, 1. Then it's going to be not -2, 5, but
Negative
2, 5.
I know that.
24. You reflected first over the y-axis. How do you do it? You multiply the x coordinate by -1. Right? Because hey, let's think about this logically, Elise. If we're going to reflect over the y-axis, we're not going from top to bottom, bottom to top, right? We're going left to right. So what's got to change? The x. Think about it. If we're sliding horizontally, what has to change? The x, because that's the one we move horizontally. So to reflect over the y-axis, to stay going horizontal, we multiply the first coordinate by -1. And look, we got the same figure. It's just a reflection on the other side of the axis. Kira.
Okay, so I have no idea. I mean, I kind of have an idea. How to do things like how to rotate polygons by 90 degrees.
Okay, so if you go back a few pages and you read the rule, it says to rotate 90 degrees clockwise. You switch the coordinates and multiply the new y by -1. Go back to page 410 with me. Ready? To rotate clockwise, switch the coordinates, multiply the new y by -1. Wait, is it time to go?
Oh, yeah.
Here's what I'm going to do for you. Ready? Any graphs, you'll have the rule visible. You don't have to memorize the rules.
Oh, we don't have to memorize the rules?
Right.
Like
If it says to reflect, I'll put the rule right there.
Okay, thanks.
you can do a whole bunch of graphs. You can just give me a test right to type my graph.
You like graphs?
No, but I was recording. No, you can just get. That's what my test is, and if I ask it's the normal test. This is right now. So are you? Is it right now? I'm here next to it, like this way.
You know how
Well, yeah.
Again, okay.
when you flip it, like when you flip it, like so let's say it was 2 to negative, or 2 to 1, and then you flip it, and then it's -1, 2.
Now, 1, 2.
Yeah.
And if you're going over if you rotate 90 degrees clockwise,
Yeah,
then it would be 1, -2.
but like, wouldn't it be, like, the 1, you just go from there, or is the 1, is 1 still y?
Look. Did you say your original was 1, 2?
Yeah, or 2, 1.
Okay. So if the original point was 2, 1, you're going to make it 1, 2, and if you're going clockwise, that's going to become negative.
No, I'm talking about the mirror.
Oh, you don't switch those. This, we did not switch the coordinates. All we did was, listen, since it's going horizontal, all we do is change the x coordinate to opposite.
All right.
Look, the y stay the same, the x's are just minus -1.
And then for the clockwise, it's just 1 negative 2.
Switch them.
Okay. Yeah, alright. Thank you. This is so
Valerie's not here today, but she always does this for me.
Yeah.
Can you do a little favor? No, I just,
Lunch, my lunch.
Here, hold on.
okay.
Actually have one.
Okay.
Alright, okay. That's what
Hopefully I can get
We're watching play. Yeah.
I don't know.
Seriously, let's play this new album.
You don't think I know how to do that?
I don't know.
Listen, Capri, in less than 2 years, you're gonna know how to take a polygon on a piece of graph paper, and you're gonna be able to reflect it to the other side of an axis.
It's literally the same.
She says, oh yeah, I've done that before. What? An app?
Yeah, it's this learning thing. Yeah, there is now.
I just realized, I'm sorry, the video's still on. So,
Hi.
Sawyer, Julia, and Johnny, sorry that you,
Hi. Bye.